Hello everyone, welcome to Programming Knowledge. Before we begin this video, there are some queries and suggestions from the previous video for which we are extremely thankful and they are to be addressed. So, the first one is that this diagram is just used to bring the three keywords in one frame and hasn't really got much to do with the union, intersection, complement or any of those operations of Venn diagram. A machine is said to learn if its performance of doing a certain task increases with experience. Also, while it's 100% correct that there are three main types of machine learning, many algorithms don't strictly fall under only one category. There are many algorithms, for example, say recommender system, that may see parts of supervised and unsupervised and come up with an optimum solution. Now that you have installed Scikit-Learn and the other required libraries, let's dive forward. Before we begin to tune or build our model, we'll obviously first need to load the data to begin our work in the very first place, right? Also, on a short note, we don't use all the data available to train our model. We reserve some part of it for testing our model. Now, why can't we use same set of data for training and testing? Simple. Because the model would already know the correct label for those instances. It is like getting same sum in exercise as it was given in solve problem section example before. Or getting the exact same question in test which your teacher taught a day before. I hope you get the picture. We'll discuss more about splitting our data in training and testing set later, but first let's get clear with loading the data first. The library itself comes with a few small datasets which are known as toy datasets, and they are mostly used for seeing the manner in which classification and regression algorithms are being implemented. Here is a list of all the standard toy datasets mentioned in the documentation of this library. Since they are pre-built, no downloading is required and we can load them as follows. First of all, we'll import scikit-learn. Now, from scikit-learn, we will import datasets. If you are interested in viewing the complete list, you can always write dir and in the bracket you'll have to write datasets. Okay, so the complete list has been loaded, but we are only interested in loading the toy datasets. So let's just name a variable, say iris, and we'll write datasets dot load iris. So now iris contains the iris dataset, and we want to know that how many samples are there, what kind of features are there, how many features are there. So let's start exploring this. We can write print iris dot. After that we can write okay, the list has been popped up. We can use data, feature names, file names. If we use the feature names, then it will actually show that what are the column headings. So let's write feature names, enter. So you can see that there are four columns. First one containing sepal length in centimeters, second one containing sepal width in centimeter, third one containing petal length, and fourth one containing petal width. So there are four columns. Let's see what's the data. Print iris dot data. So you can see it has been written that squeeze text 150 lines. So means that there are 150 examples. Let's double click on this to expand this. Okay, so as you can see, as we had seen earlier, there were four columns, and accordingly four columns have been shown and 150 examples are there. So now we know that there are 150 flowers whose sepal width and length and petal width and length have been recorded. Now let us see what are the target values and under what name are they saved. So we'll again write print iris dot target. So 0, 1 and 2 are the values in which they are mapped. So first 50. So there are three kinds of flowers. That's why we have three values. under the target section, and let us say see their names. Print iris dot target underscore names. Okay, something's wrong. I messed up the syntax a bit. Print iris dot target names. Okay, yes. So the three values which had been mapped to 0, 1 and 2 are actually the flower setosa, versicolor and virginica. For more details about this dataset, you can always write print iris dot followed by DESCR, all in caps. DESCR. This will give you a description about this dataset. Okay, let's double click to expand this squeeze text. Yeah. So as you can see, everything has been specified over here. For example, number of instances are 150, 50 in each three classes. Number of attributes are 4, which we had already seen earlier. And these attribute informations are sepal length, sepal width, and etc. The classes are also specified over here. So in the DESCR attribute, you can also find who's the author, at what time was this data set released, and other specific details. Like we used load iris a few moments ago, you can similarly load any data by typing for example load underscore digits or whichever you wish in the same way. Other than the toy datasets, the other set of real world datasets can be fetched and downloaded if necessary. These are the list of datasets that can be loaded using the fetch command. Again, this complete list has been taken from the documentation itself. OpenML.org is also a very popular public repository for machine learning data. Here's how we can download a dataset from there. Suppose we want to download this dataset of mice protein levels, which are helpful in studying associative learning. So I'll just search mice protein. Press the enter key. Yeah, this result which pops up. Here all the description about this dataset can be found, and we have to download this dataset only using Scikit-Learn. So we import sklearn, and from sklearn we import our datasets, and after that from sklearn dot datasets we import fetch open ml. After this we need to give a name to a variable, and we'll write fetch underscore open ml, and here we need to specify two things about the file. Name is equal to mice protein, and separated by version equals to 4. Mice has been loaded, and we can see the details as follows. So that is how you can download any data set from the openml.org repository. We can also generate our own datasets in Scikit-Learn using the commands which begin with make, that is make underscore. For example, make underscore classifications or make underscore regression. But we are skipping this for now, as we believe that it is relatively less important from beginner's point of view as compared to other discussed methods previously. Depending on the data and its format, we can use different libraries for it. For example, if your data is of the SQL, JSON, Excel or CSV file, then it is best to use Pandas library for it. Pandas comes with read CSV, read Excel, read JSON and read SQL commands, which make it very easy and convenient if you have files in these formats. Also, the data frames can be created of a dictionary type object using lists and tuples. But if your file is of a binary format, for example, if it has extension of .mat or .arff or .wav, then it is recommended to use SciPy library. And if there is columnar data, then NumPy array should always be preferred. And as far as the image and video are concerned, then we can load them to a NumPy array using the skimage library. All these libraries interoperate very well with the scikit-learn, and I'll leave the links related to these libraries in the description below. So by this point of time, we think that we have covered all the majorly used data forms and how to load the data in scikit-learn using them. Still, if you think that there is a data form or any method which is missed and has not been covered yet, then do mention it in the comments below, and we'll try to cover it up in the next video. Thanks for your time. This is Abhishek Singh from Programming Knowledge, and do check out other machine learning videos of this channel and make sure to subscribe. Thank you.